Today we're talking body temperature, and we're going to look at how the body reacts in warm temperature and in colder temperature. The body has two temperatures, namely the core body temperature, that's inside all the organs inside the body, that the body tries to maintain at about 37 degrees Celsius at all costs, whether it is at the expense of the hands, the nose, the ears, and the feet. It will keep the organs inside at 37 degrees Celsius, no matter how hard it's going to be for the other peripherals of the body. The peripheral body temperature, that is the temperature that's on the limbs and particularly towards the skin. And we have the saying, if the hands are cold, the heart is warm. That says that the body will keep the heart warm at the expense of the hands. Now, the organs inside, because all the metabolic processes that occur in the core of the body, those are the vital processes that drives the body. So these organs like the heart, the lungs, the stomach, the intestines, they all have to be kept at a specific temperature because the enzymes in there operate maximally at about 37 degrees Celsius. Now, there's one exception for the organs, and that is the kidneys. If I take this, for example, this is the front of the body. We've cut the body through just below the diaphragm, and lungs and heart is above here, and inside this area, this hollow of the body, we have the hollow, the coelom. We have it lined by a membrane. If you call this, you can see this membrane here. This is called the peritoneum. Now, most of the organs are inside of the peritoneum. The kidneys, however, are behind the peritoneum, that they are against the body wall, which means we have to take more care of the kidneys and keep our back warm so the kidneys can function properly. If we look at what the body does when it gets colder, we will understand why the kidneys has to be kept warm. Now, we're going to look at the body temperature on a cold day. If it gets very cold outside, our bodies try to maintain the temperature inside at 37 degrees Celsius, which means it is not going to let all the heat go out into the peripherals. And first of all, it's going to try and cut off little by little the fingers. And we see our fingers become blue, our ears become cold, our tip of our nose becomes cold. So it cuts off those areas from the blood circulation. And if we look at, for example, I'm going to take my arm and hand as a big blood vessel coming in. That blood vessel, it branches into smaller blood vessels, and those smaller blood vessels branch into tiny capillaries. And these capillaries will be cut off from the blood circulation, and we call that a capillary shunt. That is like a train is shunted this way and that way, your blood is also shunted. And at some point when the body picks up that it is too cold inside, the body is going to get too cold, it cuts off the circulation in the fingers first of all. And we will see that the blood that comes in, we can see this is a red little hook. It becomes paler as the blood is cut off, and eventually that area will turn blue because the blood in there doesn't receive any oxygen. There is blood in there, but there is no circulation in there, so the blood becomes the area becomes blue because the oxygen in there is less, and your deoxygenated blood is blue in color. So that until the temperature is restored, that will be cut off at the expense of losing that limb. Right? We know, for example, that hikers who get lost in icy mountains, they may lose their limbs, they may lose a foot, and what the body does is, let's say this is your foot, it starts cutting off the toes, and if the cold continues, if a hypothermia, if the body still experiences hypothermia, it will start cutting off the foot itself, and then eventually at the ankle, right? It's going to keep the hands because your hands are more useful than the feet. You can still crawl. So it will still first cut off the feet. And at the feet, it will cut off this whole section, the capillary shunting, will now become shunting of the even smaller blood vessels, and then there will be no blood going into the foot area, and this whole area can turn blue, and if it's long enough it will turn black, and that we say it becomes gangrenous. It is dead. I've seen a documentary once where one of the hikers got lost, and when he took off his boot, the foot stayed in the boot. That was really gruesome. But that is how serious it is, that we need to take care of how we allow our bodies to maintain our body temperature. We need to either don something, put on something warm. But if we can't, like if somebody got lost in the mountains, in an icy mountain, there's very little we can do about it. But in our everyday lives, let's say we look back again at our kidneys. Right, the kidneys, we said, they're at the back. This is the front of the body, the anterior. The kidneys are located posteriorly at the back of the body, and it is against the body wall, which means it's much more prone to become cold. Now, like we saw that when something gets cold, the blood gets cut off. Now, imagine your kidneys get so cold that the blood flow to that area is cut off. You can die. So importantly that we try and keep the body as warm as possible, particularly the back. The lungs also, if we look at the area above here, the body wall there and fat layer there is minimal. So we need to keep the back of the body warm at all times. And we know that bikers, for example, who sit with wind currents coming through, and we know that wind really cools down the body. They wear kidney belts. That is a special type of leather apparatus that they don around the body to keep the kidneys warm. It is not necessarily to maintain their shape and posture. It is more to keep the kidneys warm and keep the kidneys function properly. If we, for a prolonged period, allow the kidneys to experience lower temperatures, they may become inflamed, right? That is not infected by an infective agent, but they may malfunction because of low temperature. And we call that an inflammation. The cells there are compromised and they don't function properly. So keep those kidneys warm, because the body doesn't have the capacity to keep it warm by itself. That is one of the first areas that will experience cold if we don't take care of it. When we look at thermoregulation as such, that says it's like a fridge. The thermoregulator in there is set at a specific temperature. Our core body temperature, we said, is set at 37 degrees Celsius. So the body is going to try to maintain that at all costs. The peripheral body temperature, the body tries to maintain at also 37, because there are also things happening in the body. The thermoreceptors in the skin picks up the temperature on the outside and will relay that information to the center in the brain that helps with thermoregulation. It will either tell the blood vessels to constrict, and that says less blood flow goes to the skin, or it will allow the blood vessels to dilate, and that says more blood will go to the skin and the skin become reddish. So in very hot temperatures, we find that the body will try and protect the brain. Many animals have mechanisms in the neck or in the brain or in the ears even, depending on what type of animal it is, to keep the brain cool. We don't have that. So we have to make special effort to protect the brain against sun. And if the brain gets too hot, we call that condition a sunstroke. That says the blood vessels in the brain, they dilate, try to get rid of the heat. But if we can't stand the heat, stay out of the sun. If those blood vessels burst, we're in great trouble. Some people are genetically more prone to be able to accommodate cold, like people who live in the Arctic areas, who've been born there. Their bodies are accommodated to those conditions. Others who have been born in the desert in the heat, their bodies are accommodated. I found it very funny because I saw some people in Split not so long ago. It was almost 40 degrees, if not more, and I saw people walking with coats on, and I immediately just reminded myself they may be coming from Saudi Arabia, from Dubai, from Qatar or something like that, where it's always pretty hot, or even from the African regions along the equator, where the temperature remains fairly, fairly warm. Remember to keep your body warm. We may not be able to feel the temperature drop outside because our thermoregulators in the skin may have become adapted to it, but our body inside will feel the cold if we do not take care, if we do not protect it. And one of the ways in which the body tries to protect the lungs, for example, is to secrete a lot of liquid inside the nose and maybe a little bit more mucus in the trachea, so that as the air moves in, it warms and moistens the air so that the lungs don't dry out. We may deploy other mechanisms as well to keep the body warm, like taking in warm fluids on a cold day or taking in colder fluids on a warm day, but the choice is yours.